Welcome to Lecture 5 of Beginner's Guide to Understanding Chemistry. This lesson will be on the Octet Rule and electronegativity. So the Octet Rule. Atoms can gain or lose valence electrons. When this happens, the atom's charge changes from 0, neutral charge, to either positive or negative. Atoms do this because all atoms want to feel like noble gases. These are the elements in group 8A. They want to feel like they have 8 valence electrons. This is known as the octet rule. Atoms do this by gaining or losing electrons. When an atom gains electrons, it becomes negatively charged because electrons are negatively charged. And when it loses electrons, it becomes positively charged. We can actually use the octet rule to predict the charges of groups 1A through 8A elements on the periodic table. If you look at group 7A, these are fluorine, chlorine, bromine, iodine. We said that these have 7 valence electrons. For fluorine to feel like its noble gas neon, it would have to pick up 1 electron. Because it picks up 1 electron, it's picking up 1 unit of negative charge, and thus group 7A elements adopt a -1 charge. Oxygen, sulfur, these elements, these are in the group 6A elements on the periodic table, and they have 6 valence electrons. In order for them to feel like their corresponding counterpart neon, oxygen will pick up 2 electrons, adopting a -2 charge. Nitrogen, phosphorus, same idea. They have 5 valence electrons. They will have to pick up 3 electrons in order to feel like neon. What about the other spectrum of the periodic table? What about hydrogen, lithium, sodium, potassium? It would seem a bit outrageous for these compounds because they only have 1 valence electron. It would seem pretty wild for them to pick up 7 valence electrons to feel like their noble gas counterpart. So instead, what they do is donate their electrons. Because they're donating electrons, they become positively charged. So lithium, sodium, potassium donate their 1 valence electron to become positively charged, and this will make them feel like a noble gas. Beryllium, magnesium, same idea. Because they only have 2 valence electrons, instead of gaining 6 electrons, they'll actually donate their 2 electrons. So these develop a +2 charge. Boron and aluminum, these are in the group 3A elements. Instead of picking up 5 electrons, they'll donate their 3 electrons to become +3 charged. Carbon, silicon, these are quite interesting because they're smack dab in the middle. We're actually not going to give them a sort of charge, so to speak, but just know that because carbon is in group 4A, carbon can actually adopt a -4 or a +4 charge, being that it's equally far away from 8 and equally as far away from 0 on the other end of the spectrum. But don't worry about understanding the charges for those elements. We'll get to that when we talk about organic chemistry. And that brings us to the concept of electronegativity. The idea of this is the following. Electronegativity is an element's thirst for electrons. The more an element wants to steal electrons to feel like a noble gas, to gain a full octet, the more electronegative it is. This is a periodic table with all of the electronegative values written in for each element. The greater the number, the higher the electronegativity, the greater that element has a thirst for electrons. I will start off by saying that noble gases are not really electronegative. Because they have full octets, they don't really have thirst for electrons. So we generally ignore these in the periodic table. They have no electronegativity values associated with them because they have a full octet. They're okay. They're cool. The general trend on the periodic table for understanding electronegativity is this. As you go right on the periodic table, elements to the further to the right have higher electronegativity values than elements on the left of the periodic table. Electronegativity also increases as you go up on the periodic table vertically. By those means, this would say that francium, element 87, is the least electronegative element, and fluorine is the most electronegative element. So electronegativity trend kind of follows this diagonal line on the periodic table. In this slide, I want you to do the following homework problems. Using the electronegativity trend, identify the more electronegative atoms in each of the following pairs: carbon or nitrogen, oxygen or fluorine, fluorine or chlorine, phosphorus or oxygen. Use a normal periodic table, not one that tells you electronegativity values, to make sure you understand how the trend works.